Hello, everyone. So, today we are going to do time, speed, and distance, which is one of the most scoring topics in Quant and relatively much easier. So, what we'll do is we will go through the concepts and also go through some foundational questions. Gradually, we will move to some advanced questions, and I'll also try to inculcate previous year CAT questions. So, by the end of this session, we will be done with this topic and we can be sure that any question that comes related to this topic, we have a very high chance of getting it right. So let's get into it. Okay. Um, First and foremost, it's very important to be aware of units of measurement, especially in this topic. So we all know the general formula, right? That whenever we talk about distance, it is speed into time, and most of the questions, almost all the questions will be revolving around this one basic formula. So what I mean by that is that essentially we need to know what are the units of measurement. Distance can be measured in kilometers, but we can also measure it in meters. Speed can be in kilometer per hour, and time can also be calculated in hour. Speed can also be in meter per second. Time can also be in seconds, and sometimes it can also be in minutes or maybe in centimeters. So basically, it just about being able to match all of them in one system, and that is a lot many times how CAT frames the questions. So a very important conversion is kilometer per hour into meter per second. And if we look at how many how many meters will be 1 kilometer? So can I say 1 kilometer is 1,000 meters? And can I say 1 hour is essentially 60 minutes or 16 to 60 seconds? So if we simplify this, this becomes 5 by 18. So in general, as a thumb rule, we will remember that if you want to convert any speed which is in kilometer per hour, you have to simply multiply it by 5 by 18 so that it becomes something in meter per second. Obviously, it will not be same, but this is one of the most common conversions. So let's move ahead. If you look at the first question, it's essentially just to certain that we have understood 90 kilometer per hour. If I have to convert into meter per second, so this will be basically 18 fives are 25 meter per second, right? So that's that's it. I can say 25 meter per second. Next, if we look at the second question, before we get into it, let's understand what are the types of common problems. So usually, let's say there's a concept of average speed. So average speed is basically what is the entire journey's average speed. For example, let's say there's a train which is going in one direction at a certain speed, let's say 30 meter per second, and while it is coming back, it has slowed down to 20 meter per second. So I need to understand what is the average speed here. And the basic idea is that if it was 30 and it is 20, our mind will automatically jump to 25 meter per second, which is correct also. So the formula is average speed, total distance upon total time. Now that we are unaware of the distance, let's assume it to be d. And what will be the total time. So let's say T1 time it takes in going and T2 time it takes in coming. So average speed will be total distance, which is D plus D, and average time T1 plus T2. Also, if we talk about T1 time, can I say it will be distance upon the speed that it had while going, because the time is basically distance upon speed. And similarly, while coming, it is d upon 20. So you will see that d will get eliminated here. So this will become 1 by 30 plus 1 by 20. And basically, this will become 2 upon 1 by 30 plus 1 by 20. Further, if you solve it, this becomes 50 upon 600, 2 by this, or this becomes 60 into 2 by 5. So 24 meter per second. So how do we calculate it? Basically, we will use the formula, but it is not 25 meter per second, which is something to think about. And how did we got to this? Now that you've understood, you don't need to calculate it again and again using this method. You can simply use this formula. What will be the average speed of a train which is going in one direction at 30 and while coming back 20? So for these special type of cases, it's basically average speed is 2ab upon a plus b, which we almost derived here, because if you solve it in this way, you will see that 30 into 20 will go into the numerator, and in the denominator it will just be uh, 30 plus 20. So in this case it will be 30 20 upon 30 plus 20, and when you solve it you will come to the same conclusion, 24. So one thing that you can note in your own notebook is average speed 2ab upon a plus b, and obviously you already know, but distance is equal to speed into time, right? So now that you know average speed concept, let's do some basic questions. If you look at the second question, it is saying that a train which is 150 meters long, it crosses the pole in 15 seconds. Okay. So there's a pole, and we are assuming that the pole has no length of itself because it's not mentioned. So a train is 150 meters and it is crossing a pole in 15 seconds. Now, automatically, my mind will think that meters and seconds. So it makes sense because they are from the same uh, family of units. And now we have to find it the speed in kilometer per hour. So you have to be mindful that the answer has to be in kilometer per hour. Now, if you look at the question, it's basically speed is distance upon time, but because this time is in seconds and I need it in hours, so I will convert it into minute, then I'll convert it into hours. And similarly, 150 is in meters and I have to convert it into kilometers. So now if you look at it, what is this? 15 by 100 is in numerator and 15 by 3600 is in denominator. So basically I just want to show you in a way that you understand. Otherwise, in exam, you have to really cut through calculation. So I have to get to 36. So I'll quickly do it in my mind that, this is 50. I will see that 15 and 15 are gone. This 0 and this 0 are gone. These two denominators are gone. So it will automatically make 6 and 6 come to the numerator, and I can say 36. So the idea is keep on calculating and eventually you will get comfortable with doing a lot of calculation mentally and it will save your time. Let's go ahead. A car travels 60 kilometers at 30 kilometer per hour. Okay. So we will make a car and let it go for 60 kilometers. It's very important how you pictorially write all the information that is given in the question while you're reading it. That is also an art which will save you a lot of time. First, to judge the question if you really want to spend time solving it, and second, to solve it because you don't have to go back to the question again and again. All the information you've already noted, unless you get stuck. That is a different reason to go back to the question. So 60 kilometers at 30 kilometer per hour. Again, my mind is saying kilometers are aligned, so no conversion yet. And returns the same distance at 60 kilometers per hour. Okay. So it is going first and then it is coming back. And I will always write D here so that I know D is 60 kilometers. Find, in fact, I should write it like this. Find its average speed for the entire journey. A very direct question, but this time you will not. I mean, if you look at the average speed formula that we just learned, we could have done 2ab upon a plus b, but let me solve it still in the conventional way. While it is going, its distance is same both the times, and we have to find the average speed, which in a very basic way is total distance and total time, right? Speed is distance by time, average speed. We have to calculate all the distance and divide it by all the time. So if you look at the total distance, it will be 60. And again, while coming back, it will be 60. Time is distance upon speed, and I don't have time, so I have to think otherwise. So time was 60. Sorry, speed was 30 while it was going in one direction, and it was 60 while it was going in the while it was coming back. So again, it is 120 upon 2 plus 1 or 3, and answer is 40 is the average speed. And if we directly use the formula, then also we get to same conclusion. And now you know that the formula works, so it's worth remembering. Let's go ahead. So the fourth question is basically one of the very interesting types where there will always be a man who is either going to the office, either he reaches early or he reaches late. And in questions like that, the only trick is that you assume the basic speed as S, usually, the basic time as T, and the basic distance as D, and then you make the information into equations and it becomes very easy to solve. That is the only way to solve these type of questions. So the question is that walking at 5 kilometers per hour, we are on fourth, right? A man reaches 6 minutes late. So I know that it is walking at a speed of 5 and it is reaching 6 minutes late. So it is taking 6 minutes more. And he reaches 2 minutes early when he goes with a speed of 6 kilometers per hour. So this you have to remember that the speed is kilometer per hour, but the time is in minutes. I'm assuming my t time also in minutes, and it is reaching 2 minutes early, so it is taking 2 minutes less time. Now we have to find the distance. So always write in the corner what we need to find. Our eye should always be on the final output. Now, basically, whatever distance it was traveling, okay, I'm assuming it D, so let's not get confused. D is what I need to find, and distance is speed into time. So this is obviously always the by default equation. Again, distance will also be the new speed, which was 5 kilometer per hour, and the new time because distance remains same, and distance will be 6 kilometers per hour and time. Now the thing is that most of the time we will be equating, so even if it is in minutes it will get cancelled, but as a thumb rule, whenever you're writing this, you should write that 1 by 60 to the time, so that it is again now distance is in kilometers because speed was kilometer per hour and time is also in hours. So now distance is coming in kilometers. Similarly, we will do this. Now, if you look at the second and third equation. It's pretty easy. I just want you to know the basics, and then we will speed fast our process. Because once you understand the concept, it becomes very easy to do calculation fast. So if I equate 2 and 3, I know 1 by 60, 1 by 60 will get cancelled. And if you open it in your mind, it is 5t plus 6 and 6t minus 2. The way I will do it, I'll see 6t here and I am seeing 5t here. So I can directly write t here. And this is minus 12. This is 30. So 30 plus 12. So I can simply write that. But just so that you get comfortable gradually, I'm showing you. 5t came here, 12 came here, and it became 42. So I know time is 42 minutes or hours. So it is again minutes because I've assumed it in minutes. I've converted it into hours here. So 42 minutes. And I have to find distance. So I can put it in anywhere and calculate it. I also need to, any equation will work. So 42 plus 6, 1 by 60. This is 12. This is 48 by 12. And answer is 4 kilometers. So pretty basic, but important because most of the time CAT is not giving directly such questions. It will always try to complicate either the language or mix it with some other concept. But nevertheless, if you're comfortable with this, your chances will increase to solve more complex questions. Again, this is a very important type, question number 5. If you look at it, the train that was passing the pole, in case we get two trains and we let it pass each other. So what happens is, always if there are two objects which are moving towards each other, relatively they will see that they're moving very fast. For example, if you will see a tree at a distance from a train which is moving, and a if you will see a tree and if you see a tree which is also on a train which is moving towards you, suddenly you will see that the tree is moving towards you very fast. So that is called relative speed, and that is the basic concept, that if there are two objects which are moving towards each other, their relative speed will increase. If they had speed a and b, their relative speed will actually be a plus b. And if they're moving away from each other, again, if they're moving away from each other, if this guy was stationary, he will move. But if this guy is also moving in the other direction, he will see him moving very much faster compared to if he was stationary. So again, in this case, the relative speed will be a plus b, because this will come in the concept of all the questions. So this time, this is case 1 where the speed gets increased. This is case 2 when A is chasing B who's running away. So in this case, if he was stationary, A would have reached very fast. But because he is also moving, A will not reach as quickly and it will take some time. So in this case, the relative speed of A has decreased. So relative speed in this case will be A minus B or B minus A. If it is A minus B, that means A speed is more and it will catch. If it is B minus A, that means B speed is more and it will never ever be able to catch, and B will always keep moving and stay ahead. So that is the major concept in all of questions like this, and you will understand it better once we are done with a couple of foundational questions on this. So let's do it. Um, in this case, if you look at it, their train's length is given 120 meters and 180 meters. Keep in your mind it is given in meters. And they're moving in opposite direction. Okay, so opposite direction, it can be this. Opposite direction, it can be this also. Let's see. So they're moving in opposite direction. Find the time they will take to cross each other. So since they're crossing, it's definitely this case. And find the time they will take to cross each other, 54 kilometers per hour, 36 kilometer per hour. You know, this time the speed is going to increase. Always remember, don't think too much in the exam. Think to understand and then learn. So when they're coming towards each other, speed will increase. When they're moving away from each other, again speed will increase. So if they are in opposite direction, speed will increase. If they're in the same direction, speed will decrease, right? So opposite, speed will increase. If same direction, speed will decrease. That is the concept. Okay. So again, very basic question. What will the time they will take? So 120 meters plus 180 meters. Why are we adding the distance? So look at the train passing. Okay. This train just reached here after some time. Then the train reached here after some time, and then the train reached here. Essentially, if you look at it, how much is this? There's this ant here. How much distance is the ant covering? First, the ant is going total 180 meters, and the ant reached here. Then the train hasn't passed. So this ant will reach till here, 120 meters more, then it is has essentially crossed the entire 120 plus 180 meters. So that is why when two things cross each other, they have to you have to add their lengths, or you have to add their respective dimensions. So 120 plus 180, 54 plus 36. What is wrong here? This is kilometer per hour and this is meters. So make it kilometers. Now you know this is going to come in hours, and I have already seen that the answer is in seconds. So better way to do it is, this is in meters. Let's keep it in meter per second. I want this in seconds, so let's convert this kilometer per hour into meter per second. So what is this? 300. What is this? 40 and 50. See, don't once you get relatively good. You don't need tips, but just some food for thought. I know 54 plus 36, so I can see it as 60 by taking it 6 and 30, so 90. Just a way to see it. So 5 by 18, now you cross the zeros, and you can see that, you know, when you don't get any idea, just keep shortening it. So this is what? 50 by 3 into 18. So this is in find the time they will take to cross each other. 5, 6, 7, 8, 90, 300, 3 and 10. Some calculation mistake have I done. Okay, so I've done a very classic mistake. You're converting kilometer per hour into meter per second. So this is 5 by 18 in the denominator, and look what I've written. So it will become 18 by 5 when it will go to the numerator. And that is why the answers were coming in complex digits while the options were whole numbers. So it will happen to everyone, and it's important to not doubt your concept, but just reassess quickly. So it is 12, and pretty basic question, but quite important for the concept. Let's go to next question. Okay. Um, this is also a very important type where we talk about upstream and downstream. And let's understand the concept. There's a boat, and this boat has to go up the mountain, and it's gonna take a lot of efforts, right? So, but once it reaches at the top, and while it is coming back, it becomes fun because the efforts will be very less while coming down. So in every way, there is always a stream's own speed. For example, if the water currents are, in our favor, then it helps. It gives me a boost. And if the water currents are against my favor, it increases my efforts. So in any case, you have to always remember that the speed of the stream we assume as v in general, and the speed of boat, or the speed of the man who is rowing the boat, will be u. Let me make it like U. And in general, if we look at it, while I'm going upstream, let's say the river is in this direction, okay? So if you look at it, my relatively, I would have climbed with speed U, but because there is water current, my speed will get decreased by U minus V. And when I'm coming downstream, it's only gonna help me in reaching fast. So it will become U plus V. And this is the crux of all the questions in downstream and upstream. Okay. So let's do a question. A boat covers 30 kilometers downstream in 2 hours. Okay. So as soon as I get this information, I will see that the stream length is 30 kilometers. In my mind, kilometer per hour mindset is there. And it goes downstream, which means U plus V. And it takes 2 hours. And then it goes upstream in 3 hours. And upstream speed is this. Now find speed of the stream, not boat, stream. So we have to keep our eyes on V. So it's basically distance is speed into time, and both the time distance is same. U plus V into 2 is the distance, speed into time, and U minus V into 3 is again the same distance, which itself will be 30. So if you look at these two equations, you can see 3U, you can see 2U. So 2U goes there and becomes only U. You see minus 3V here and plus 2V here. So it becomes 5V. So you can like really do it faster. And this is your first information. Now what? So pick any equation and solve it further. So it becomes like this, and I have to calculate V. I don't need U. So eliminate U rather than V. So U will be 5V. So this is basically what? 10 and to 12. So our answer is 30 upon 12. Just a second. Hello. Yes. बताइए. Spam call. Anyway, so if you look at it, it's look at the options. 12 to the 24 and 60 so 2.5. It is easy calculation, but most of the time, if it is too much calculation and you know it is 2 point something, look at the options. Only go till the digits that you can eliminate all the options. You don't need to calculate the exact uh, option. You just need to pick the right option. You know? So do calculation in the depth that is required. Again, a man can row. Let's look at the question. It is also from the same concept. And it says a man can row 12 kilometers in still water. That means if there's no stream speed, the boat speed is 12. So if it can row in still water at 12, U is 12. River flows at 4. So that is basically stream speed, which is V. How long will it take for him to row 24 kilometers downstream? Very direct question. So distance I know, and everything is kilometer per hour. Answer will also come in R. And downstream, so U plus V. So 24 by 16, 8, 16, 24, 8 to the 16, 1.5. Very direct question. Uh, it will just make you very sure about this concept. That is why I'm taking all of these questions. Let's go. This is also another type, which is very important type. So it's basically there are two people who are racing each other, and most of the time, what happens is that one of them will reach the finish line first, and when once they reach the finish line, the slower one will be somewhere um, away from the finish line. And if you look in this example, let's say it was a 1 kilometer race. So A actually did 100,000 meters, but B, let's say there was 100 meters left till A finished. So B actually did only 900 meters, and they both took same time because it's a race, right? So time did both took T, and because they had different speeds, their distance will be different, right? You always need one thing constant to compare. Now, most of the time, if someone is overconfident, they will say that, I have given a leeway to the other person of some certain distance. So A is saying that let's race, but you start somewhere ahead, and I'm giving you 100-meter advantage, and then let's see who wins. And again, let's say A wins. Okay. So A has done a distance, let's say this is 900 meters, and A has again done 100 plus 900 meters, but B has done only 900 meters. And in this case, depending upon the question, we will see, but that is the whole idea. And it doesn't matter how much in depth you want to go with the concept, there's no limit to it. The best way is solve a few foundational questions, get your concepts mastered, and go for previous year CAT questions because they are the level that we are aiming for, and then maybe just for fun do a few advanced questions so that you're done, you're sure about that particular topic. So in this case it's a 1,000-meter race. A beats B by, again it's the same example that I took, that when A reached here, B was 100 meters away from the finish line. um, So A speed is given as 10 meter per second. Always write the question also like this so that information also gets very nicely assembled. And that is the whole point of solving it in front of you so that you also get an idea how to use your rough work. You have to come back also in questions that you get stuck. So it should be easier to pick up from where you left. And now we have to find the B speed. So you have to keep in mind that I need to find speed of B, SB. This is the way you annotate all that information. Distance covered by B, time taken by B in general. So what just happened? 1,000-meter race. A speed is 10, B speed we have to find, and it's a very basic question. Again, because it was a race, time is constant here, time is distance upon speed. So distance covered by A is 1,000, its speed is 10, and distance covered by B was 900, and speed was B. So speed of B will directly come as what? 9 meter per second. Very basic question, but you get the drift. So question number 9 is saying that A can run a kilometer race in 4 minutes and B can do it in 5 minutes. So basically I have the speeds. Speed of A will be 1 kilometer and 4 minutes. So in meter per second I know. And similarly speed of B I know is this. Since they're both starting together, I know they would have covered, A would have reached here, but B is slower. So B would have reached somewhere close to the finish line, and that's what it's asking by what distance it beats. So I will assume X to be this distance that B was not able to cover, and the distance by which A was beating B. If you assume X to be the distance that is covered by A, be sure that the question is asking 1,000 minus X now. And to it's a human nature that whatever you assume to the value, whatever you assume X as, and as soon as you get the value, you will hit the options. So it's important to assume what you need to find to avoid those mistakes. And here I will assume this as X, and the distance that B has covered in that same time will be 1,000 minus X when A covered 1,000 meters. So when B covered 1,000 meters with its speed of with its fastest speed, you know, so I know it will be less than 1,000. So basically the multiplication factor will be 4 by 5 and not 5 by 4. So it's like common logic that if you have to reduce the number, it has to be less than 1. And in this case, because speed of A is time taken by A is 4, and time taken by B is 5. So if I need to find the distance covered, I have to multiply it by 4 by 5, which is 800 meters. So I know that B would have covered 800 meters by that time, and 200 meters should be the answer. Okay. So let's go to the 10th question. Excluding stoppages, this is again speed and train, all of that. So let's go to the next question. Again, train type of questions. So excluding stoppages, the speed of train is 60 kilometers per hour, and including stoppages, it is 45 kilometers per hour. So what does that mean? The train is stopping at platforms, and because of that, overall its speed has decreased, and we need to find the stoppage time. So if there was no stoppage, it would have taken t time. Because there are stoppage, it will take some more time, which I'm assuming as t dash. T dash is the time. Find the stoppage time per hour. So I know that t dash is what I need to find. And because it is saying per hour, so I can assume that the time is also given as 1 hour, and I need to find accordingly t dash. Okay, let's say that per hour we will use later. Let's understand it in a basic way. So what is happening is the distance is same, but the time is more, and that is why the speed is getting influenced. So let's say the distance is speed into time, and it is same as speed into the other time. And if you solve it, it will become 45t will come here, and it will become 15t, and 45t dash will remain here. So I know t is 3 times t dash. Okay. And because it is saying in 1 hour, I know that in 1 hour it will be 60 upon 1 hour is 60 minutes, right? So 20 minutes. Question number 11. What is question number 11 saying? A train crosses 100-meter long platform in 25 seconds. Okay. So this is also important that you picturize it so that it becomes easier for you. Let's say this is the platform, and the train, it is 100 meters, and the train crosses the platform in 25 seconds. So to cross, it's the same ant wala concept that the train has to cross, right? So not only it has to reach here, but it has to also get completely away from the platform. So the train has to like really get to this point to be able to cross. So it is not only covering 100 meters, but also its own length. So in such cases, don't think so much, just add the distance. So I'm assuming the train's length to be L. So it is 100 plus L, and it is doing it in 25 seconds, meter per second. So this is basically speed of train from the first information. And it crosses a pole in 15 seconds. So again, the same train is crossing a pole in 15 seconds. So essentially, pole has no length. So I can simply use the other equation for in a way that 15 seconds is what the train is taking to cover its own length L, and it is again it is same as speed of train L by 15. Find the length of the train. So I have to keep my eyes on L, and if you equate the two equations, it simply becomes 100 plus L, and 15 and 25 can be reduced as 5 and 3. And if you look at it, this becomes 300, this becomes 5L, this is 3L. So 3L will go here 2L, and this is 300, so L is 150. So you can proceed. Let's go. Again, the question is kind of, next question is also a repetition of, um, upstream, downstream type of questions. And the idea of mix and matching is that you can pause the video, try it yourself. And if you're able to do it, you've understood the whole concept. Let's quickly do it. Speed of the boat in still water is 15. So you know for U is 15, and speed of the current is 3. Find the total time taken to row to a place which is 84 kilometers away and back. So the boat is going up and then it is going down. Find the total time taken. So total time taken will be first, what will be T1 plus T2? T1 will be 84 kilometers upon the speed while going up. So it is 15 plus 15 minus 3 because it's gonna decrease my speed, assuming that the current is going here. And it will be 84 upon while we are going down, the speed is going to increase And you're saying that why are you assuming that the stream is here only? So you can assume stream to be here. Matlab, it can be in this way that first you're going downstream, then you're coming upstream. But in that case, also you will, when you're going downstream, you're going to do this. When you're going upstream, you're going to do this. So it doesn't really matter. It's the same thing. So you can assume one and move ahead. And usually, whenever you say downstream, assume this situation. Whenever you say upstream, assume this situation. Find the total time taken. So it's basic calculation, and basically calculations are never going to be this easy. But because we are doing concepts, CAT will judge you majorly on calculation. So how will you do it? You can totally see 84 first of all as coming common, and you can totally see 6 coming out, and you can see 1 by 2 and 1 by 3 staying in the bracket. 6 1 is 6, 6 12 18 24. And this is what 5 by 6, and if you look at it and reduces further, 35 by 3 or 11 point something, and you look at the B option, the only option with 11 point something. So go ahead, don't solve the entire thing. Keep your eyes on options all the time. Don't calculate what is not mandatory to calculate and waste your time. A car covers a certain, sorry, question number 13. A car, two-person start from the same point, walking in opposite direction. Person A. Again, this is also that type, right? Which I explained. 4 and 5. And after how long will they be 27 kilometers apart? So basically, this guy will come here, this guy will come here, and then they will be at one point of time 27 kilometers apart. But it can be like A must have covered lesser distance, B must have covered much more distance because B moves faster. So you know that overall they've covered 27 by half. And again, I told you opposite direction, you have to add the speed because they will be increasing their distance faster. How long will they be 27? The time, distance upon speed. Speed, you know, has to be added. So basically 3 hours. Very simple. A car covers a certain distance at 8 hours in 60 kilometer per hour. At what speed should it travel to cover the same in 6? Again, you know that when it is at 60 kilometer per hour, it is covering in 8 hours. Now it is to cover in 6 hours. So the speed has to be increased. So very quick ways, you know 60, either I will multiply it by 8 by 6 or I'll multiply it by 6 by 8. Basic unitary because they are, directly proportional. So if you look at it, I know that the speed has to increase. So this is the case because you have to cover it in lesser time. So in this case, the answer is 80. If you do it with proper concept also, always do it like this, but just because we are here for basics of our foundation, you can look at it that let the distance be d, and d is 8 into 60. At what speed should it go for, let's say, x speed to cover the same distance? So when you equate all of this, it becomes 6x is equals to 8 into 60, or x becomes 8 into 60 into 8 by 6. So that's how I'm telling that if everything is concept and constant, and you're just comparing one thing to another, you can directly use unitary method. um, Let's go. Question number 15. A man walks at 4/5 of its usual speed. In general, assume speed to be s, time to be t, and by 4/5 of its speed, it reaches the destination 10 minutes late. It is taking 10 more minutes. Speed is in meter per second because time I'm taking in minutes, and t is also going to come in minutes. And this is also very basic, very common type of questions where a man is either late or reaching early to a certain place, so different situations. And find is you okay, this is very direct question. Find is usual time to cover. So basically distance is speed into time, and it is also speed into time. So again, s and s will get cancelled. 5t here, 4t here, so 40 will come here and 40 will remain here. So time will be question is all over. So time is 40. Hey, it's not in the option. Have I done some silly mistake? Sorry, it is. Question number 16. I looked at the options of the next question. Question number 16 is speed of A and B are in the ratio 3 is to 4. How do you use this information? Just make it 3s and 4s as their speeds. A takes 20 minutes more than B. So A takes 20 minutes more than B. B time, let it be T, and this can be T plus 20. This speed is now automatically meter per second. T is automatically in seconds. Sorry, minutes. In this case, time is in minutes because it's easier to calculate and it's easier to write it like this. Alternatively, you can directly make it uh, 20 minutes as seconds also. So in that case, you know that time you are assuming in seconds, but options are in minutes. So don't overthink it. Simply assume that whatever time I'm going to calculate, it's going to come in minutes, and speed I'm assuming in meter per second. Okay. Now, 20 minutes to cover the same distance. You know? So distance is same. Distance is what? 3s speed into time. The thing is that whatever, even if I convert this entire thing into seconds, no, it will get deducted. It will get cancelled. So there should be no confusion in that case. I will write it t plus 20 into 60 because it's meter per second. So now the distance is also going to come in meters. So basically, I don't want you to be confused. It's just going to get cancelled. That's why I was not caring about it. 4 second into t into 60. So you saw the 60 getting cancelled. That's what I was telling. And because it was 3s and 4s, s got cancelled. So you could have directly taken 3 and 4 also because you know it's a ratio, but it comes with practice. It's okay. 4t minus 3t becomes t, 3 into 20 becomes 60. So we know time will be 60. But what is it that we needed to find? Time taken by A. And time taken by A, I have assumed as t. No. Time taken by B was t. Time taken by A was t plus 20. See, that's how it can become a silly mistake. So answer will be 80 and not 60. Because we are asking time taken by A and not B. A cyclist covers, if you don't want to get confused, you could have assumed time taken by A as t and time taken by B will automatically become t minus 20. So in that case, you know, whatever answer comes is the answer. But since this time I took t as speed time taken by B, and while I was going to the option, I was committing the same mistake, but I was being mindful. What is the value that I have found? What is what the question is asking? So a cyclist covers a distance in 40 minutes at an average speed of 24 km per hour. Find the speed required to cover the same distance in 30 minutes. Very direct question, right? We just did this type of question. 24 kilometers per hour, and this is when he wanted to cover the distance in 40 minutes. Now he wants to cover the same distance in 30 minutes. Obviously, is to increase his overall speed. So it will be 40 into 40 by 30 or 8, 16, 24, 8, 16, 24, 36. Two cars start at the same time from 300 kilometers apart. So let's say this is car A, this is car B, and they are 300 kilometers apart. And they travel towards each other at 40 and 60. It's not saying respectively, but that's a very important word. So if it was a longer or more complex question, we have to be mindful that are we sure 40 is A speed and 60 is B speed, but in this case it's just two cars, so I can assume. But I just wanted you to be mindful about the word respectively. After how long will they meet? So now they're moving towards each other. As I told you, opposite speed you have to add because they're gonna see each other coming together very fast. So it will be 100 and distance is 300. So time is total distance upon total speed, or they will take 3 hours. A man rows 12 kilometers upstream in 3 hours. So how do you write the um, information? 12 kilometers upstream in 3 hours. So U and V don't forget, okay? So U plus V, U minus V upstream, 12 by 3 and downstream U plus V distance upon time 2 hours. So find the speed of the stream. You need to find V. So basically, it is just two equations and don't add them and find U. Directly subtract the two equations and find V. So if I subtract 1 minus 2, so this becomes V minus minus V, so 2V. This becomes 6 minus 4, so 2, so V is 1. Let's go. Walking at 3/4 of his normal speed, walking at 3/4 of his normal speed, a man reaches his office 20 minutes late. So again, last question, but very common type. So let's assume the normal speed as S, normal time as T. If it is 3/4 of his normal speed, a man reaches 20 minutes late, or it takes 20 minutes more. Find its usual time to cover the distance. Distance is speed into time, or speed into time. Again, if you look at it, ST, 3 by 4 ST. So if it comes here, it becomes 1 by 4 ST. And here it is 5 4s are 20, 15 S. S and S get cancelled. Time comes out to be 60. Now, what is this 60? It is minutes. Could have been in hours, right? So that's about it. Thank you so much for joining. And I want to take good questions if you are comfortable with this foundation, which you should be, because these are enough questions to know the concept. Join in for the next hour where I will basically take all the questions that have come in last 5 years of CAT exams, all the slots. And I think once you've done with that, you can be very sure that you've mastered this particular topic. So I hope this helps. I will attach the assignment in the comments and you can give it a quick go so that foundation is done. And before you join for the solutions of the advanced assignment, I would really request you to go through that, spend some time solving it, and then come to the solutions. All right. Thank you so much for joining, and I will see you in the next class.